If we have special angles that we can use our hand trick for, that's great. Or if we have special values that we can find a theta for because we have a special value for tangent, then that's wonderful. But that's not always the case. And when it's not, sometimes we have to use our calculator to find an approximation. On the part A here where we start in trig form, really the only thing to do here is to type this in your calculator. Remember, the weakness of doing this is that if you don't set your calculator to degrees or use the degree symbol in your calculation and your calculator is set to radians, then you're going to get the wrong answer even though it looks like you're typing it in correctly. So you have to be careful of that. But otherwise, you're just going to type this into your calculator to get the answer. Let's just take a look at that really quick. We want to be on a calculator page. And then, of course, you want to check your settings here and make sure that your document settings are in degrees, because my problem is in degrees. My calculator is in radians, so I make that change, and then I can just type this in. Don't forget your parentheses, because the 6 in this case has to be distributed through the cosine I sine. So we're going to start with cosine, and our angle was 115 degrees. Watch your parentheses. You need the I, not the letter, but the I that's on the pi button, and then times sine 115. Okay, and what you get back here is a decimal, a little expression here that has decimals in it. But since our angle is not one of our special angles, then that's what you can expect. That's all you can do. And so that's your answer, as long as you round to the nearest whatever they tell you to do. I think usually they say the nearest tenth, but just go with whatever the problem is. Notice that you have the I here indicating that this second term is the imaginary number. That's all you have to do when you have a non-special angle on your problem. Let's look at the second one, though, because it's not as simple to take this rectangular form and change it back to trig form, even though it's not going to be a special value for the tangent inverse. So we're going to go through our same process, and we're going to draw a sketch first to get from rectangular to trig form. First thing we're going to do is sketch this complex number, which has a real value of 5 and an imaginary value of -4. So that puts us down here in quadrant 4. If we label this resulting triangle that we get that always goes to the x-axis, never to the y, then we're going to have 5 here. We're going to have -4 here. We need the r value, that's the hypotenuse, so we're going to take the positive square root of 5 squared plus -4 squared, which gives us the square root of 41. If you put that in your calculator, of course, you're going to get a decimal, and it's not the decimal that they want here. They're going to want most likely, they're going to want the square root of 41 as your r value. And then you have your cosine I sine. Remember, the theta is the same for both of those. And to find your theta, you're going to use tangent inverse. So we're going to say tangent inverse of our tangent value on this triangle, which is opposite over adjacent, -4/5. Now, before we actually take this to the calculator, let's think about it first so that we can figure out what our calculator is telling us. Usually these instructions here are going to say to give your angles for theta between 0 and 360. And they usually include 0 and not the 360 degrees. Or they might tell you to do this in radians, but we'll do it in degrees. So think about what's going to happen when I ask my calculator, where is tangent equal to -4/5? Well, first of all, the hand trick won't work because 4/5, you can't make that happen on the back of your hand. So we know we have to go to the calculator for that. But remember that the inverse trig function here is either going to occur on this top bubble, which is quadrant 1 and quadrant 2, or if it's tangent inverse, it's going to occur on this side bubble right here. So the positive quadrant is 1 and the negative quadrant is 4. So we know that the calculator is going to give us an angle down here that's in quadrant 4. the angle the calculator gives us is going to be a negative angle, because that bubble actually goes from negative, we'll say negative 90 degrees to 90 degrees, which means that this angle is going to be given to us as a negative angle. If we want our theta to be between 0 and 360, then we're going to have an angle that's coterminal to that one. So we ask our calculator for this information, but we have to think about it a little bit further to give the theta that they're asking for in the problem. Now let's go to the calculator and see what that looks like. So again, I'm in degree mode, so I'm going to get a degree answer, and I want tangent inverse, negative 4/5. Once again, let's approximate this, and I get what I expected, a negative angle here. Remember, I want an angle that's coterminal, that still terminates in quadrant 4 in the exact same place, but is positive. So I add 360 to that, and I get 321.34, and there's other decimals after that. I'm just going to round that to the nearest tenth unless it tells me something different. So 321.3. Remember to put the degree symbol on there, or if you don't, it's assumed to be radians, and that would not be correct. So this is the trig form of that complex number.